welcome back to my office hours. In this video, let's work on an example problem of needed fire flow estimation using the ISO method. Problem statement. Using the Insurance Services Office or ISO method, estimate the needed fire flow in gallons per minute for a building described as follows. 1. The building of construction class 3 comprises 4 floors, with floor areas measuring 7,000, 5,000, 5,000, and 3,000 square feet, respectively. 2. The building is used for dormitories. 3. All vertical openings in the building have 1 hour or more protection. 4. All the doors are self-closing and labeled as Class B fire doors. 5. The building's distance to the exposed building is 55 feet 6. The building's facing wall to the exposed building is masonry with semi-protected openings. 7. The length-height value of facing wall of exposed building is 650. 8. The passageway openings are non-combustible and enclosed with a length of 10 feet 9. Single Class B fire doors are installed at each end of the passageway. Solution. To solve this problem, we know that the ISO method has a simple equation. That is, NFF equals to construction factor C times occupancy factor O, then multiplied by 1 plus the sum of exposure X and communication P factors. Let's find out each of the factors with the information provided. First, let's look at the construction factor, which can be calculated using an equation related to the coefficient F and the effective area A. We must know its construction class to determine the coefficient F. In this problem, the building is in construction class 3, corresponding to AF value of 0.8. Next, let's find out what the effective area is. For buildings of construction class 1 through 4, it includes 50% of all other floors. For buildings of construction classes 5 or 6, provided that all vertical openings in the building have 1 hour or more protection, it consists of 25% of the area, not exceeding the 2 largest floors. In this problem, we have a building of construction class 3. Therefore, we calculate the effective area using 7,000 plus 50% of the sum of 5,000, 5,000, and 3,000 square feet. The result is 13,500 square feet. Therefore, the construction factor C is 1673.129 gallons per minute. It is within the range of C for construction class 3. The value of C should be rounded to the nearest 250 gallons per minute. In this case, the nearest 250 gallons per minute from 1673 gallons per minute is 1,750 gallons per minute. We always round it up rather than rounding it down. Second, occupancy factor O. The occupancy factor reflects the influence of the occupancy in the subject building on the needed fire flow. It is directly related to the items typically stored in the subject building. In this problem, we have a dormitory building. According to the combustibility classification, it is in the second combustibility class. Hence, we have an occupancy factor of 0.85. Upcoming next, let's talk about the exposure factor and the communication factor one by one. To find the exposure factor, let's first focus on the construction class on the top rows of the table here. In this problem, we have a building of construction class 3. Hence, let's focus on the column corresponding to construction class 3. According to the statement, the building's distance to the exposed building is 55 feet, so we can narrow the rows to focus on in this table. Additionally, we know that the length-height value of facing wall of exposed building is 650, which is over 400. Now we can lock the value for exposure factor in this problem. That is, 0.15. Finally, let's take a look at the communication factor P. In this problem, we are told that the passageway openings are non-combustible and enclosed with a length of 10 feet, and that single Class B fire doors are installed at each end of the passageway. The first information regarding the passageway opening being non-combustible and enclosed helps us narrow down the columns of concern. We also know that the passageway openings are enclosed with a length of 10 feet, therefore, the column for finding the communication factor can be located. By knowing that single Class B fire doors are installed at each end of the passageway, we can find that the communication factor P is 0.10. At this point, we know that x is 0.15 and that p is 0.10. Therefore, x plus p is 0.25. In summary, construction factor is 1,750 gallons per minute, occupancy factor is 0.85, exposure factor is 0.15, and communication factor is 0.10. We can finally find that the needed fire flow NFF is 1,859.375. Because this NFF value calculated is smaller than 2,500 gallons per minute, we will round it up to the nearest 250 gallons per minute. Therefore, 2,000 gallons per minute is our estimated needed fire flow. Thanks for watching. Leave a comment if you have any questions.